investment, the utility, the benefit for the in terms of water management can be reduced. So that I took a cue from that, and also very interestingly, he spoke about waste to wealth. I would like to say that it's a tremendous vision, waste to wealth. It is also an interesting point that generally we go from wealth to waste. We take water, which is a precious commodity, it is a great wealth of our country, and we put it to waste, and a lot of water is lost in leakages. Generally, as a statistic, I believe more than 30% is the losses from our municipal water distribution system, 30-40% losses. And in terms of irrigation water, 30-40% accounted water, and the rest is losses, So while we have the leaders of our nation leading us from waste to wealth, it becomes the responsibility of all of us to go and make sure that we do not put wealth to waste. Now, on that note, just let me go into the subject on hand here. When we think of automating nowadays, there is requirement for automating wastewater treatment plants, water networks. There is a lot of requirement for automation. But in the beginning, when this is conceptualized, there needs to be thought of what is the end result that we are trying to achieve. A lot of discussions on wastewater treatment, which are the areas which are energy consuming. How can an automated system help you dissolve oxygen control in an aeration lane, for example, from a wastewater perspective? Leakage losses in a water network. What are the end results that we want to achieve? So really there is a need to begin with an end in mind. So this is a point that is often missed in defining the specifications of an automation or a measurement system. And there is a need to manage contradictions. 24/7 water supply, at the same time reduce NRW, not revenue water. That is a contradiction that has to be managed. Now, how are you going to get 24/7? God gives us a certain amount of water to manage. The only way to do it is by preventing leaks and continuing to prevent leaks. How is that going to be achieved? These contradictions management is an important process in visualizing the end result in any automation project, call it smart city or any development 24/7 water supply. Now, no automation or measurement system will work, it will serve a purpose if the data that is coming into it, you are measuring dissolved oxygen or you are measuring flow, you are trying to account for the volumes of water that comes from a water treatment plant and try to match it with what is being distributed. Nothing is more important than the instrumentation that you put in from which the data is coming out. And in terms of instrumentation, accuracy, reliability of measurement, long-term usability, all these are aspects that we talk about often. We need to also talk about not initial capital cost, but lower cost of ownership of instruments, which means that if you have to replace an instrument every so often, over a 10-year period, you would pay for 2 instruments instead of 1. So, look at the reliability aspect, the material of construction of the sensors and these sort of things, which will make sure that you get the sensor life and the performance that you want from your plant or network. So that is, and reduction of non-revenue water. So that is the end result you are looking from the instruments that you invest in. In terms of the monitoring and control, computerized systems, in today's world, our digital India, we talk about reduction in cost, obviously. Nowadays, telemetry, bringing information to a central location is not as expensive as it used to be, and it is a lot more reliable now than what it used to be. The communication options, telecommunication options, and the reach that we have in our society, in our infrastructure, means that you can bring information back quite economically into a central system, but it needs to be defined when you define the scope of a monitoring and control system. Now, nowadays it is open web-based technology. Of course, the note of caution is when anything is web-based, there is always some virus or some attack hovering in the background, So it needs to be protection, firewalling, etc. needs to be very well defined in building up monitoring and control systems. Now, also nowadays most of the construction happens in the municipal sector, definitely, with a certain operation and maintenance period built into the contractor's responsibility, 10 years. At the same time, the owner wants to keep noting how the contractor is performing. What is the result? Am I reducing my non-revenue water or am I increasing non-revenue water? Now, you want to know what parameters you have envisaged that your contractor should be doing, and is he actually achieving it? Systems are tools to help you to monitor that without running around all over the city trying to gather data. The data can come to you on your desk nowadays with the technology. So that's the concept about leveraging the technology. So we need to make sure that the information for effective supervision of O&M contractors is available. And then there should be the business process that you want to reduction in leakage, non-revenue water, or reduction in number of people you need to operate and maintain, because we have an ever-expanding network so you want to be able to manage with your available resources. More infrastructure, more area, means that there should be a concept of how you are going to manage the infrastructure. Also just a small point to note is we have had traditionally a way of doing things in our country, and we have had certain results. Conferences like these, they are leading into convergence on how things can improve. We have visionaries who drive us forward on improvement. Now, if we keep doing things the way we were doing 20 years back, we get the results that we were getting 20 years back. Managing contradictions, just quickly to run through that. Increasing demand versus reduced availability of water. The need to manage larger water networks with available resources. 24/7 water supply against non-revenue water reduction. Improved energy efficiency while distributing more water to more people. Uniform equipment operation while you have varying conditions. So you don't want one pump running 24 hours a day and another running 6 hours a day in another location. So how do you ensure uniform equipment operations while we have varying demands and varying circumstances? Water quality is a variance, from the source in your water treatment. There could be variation in the raw water quality, which then still you need to give consistently the water quality for the users. Now, end results in terms of what are the end results that we are looking in terms of instrumentation and control systems. A lot of technology options are available now. We have come through phases where we have very limited technology in terms of how do we measure water flow. I'll talk more about volumetric measurement because that is single most important parameter. Of course, there is water levels in storage tanks, overflows, there is pressure in our water network, so many different parameters, water quality monitoring. Many parameters are there, but as an example, we can quickly talk about flow measurement. We have many technology options, and we have to apply the right technology in the right place. There is electromagnetic measurement, there is ultrasound measurement, for example. Certain things are applicable. If you want to put a flow meter on a very large 1.5 meter diameter pipe, and you say, I will cut the pipe and install the meter. Where are you going to be able to isolate your network? How will the meter get installed? What is the risk of cost and time overrun? So, whereas is there another technology which you can install without significant modification to your existing pipeline. So this is what we are selecting the right technology for measurement Then when you are retrofitting, you have some working instruments which you have already invested in. So you want to make sure that you are able to use that and build it into a new system, protect the investments that are already existing. And so that is about retrofitting into existing scenario. And also your pipeline, you know, it is used to working in certain pressure. It may be working normally at 2 bar or 4 bar pressure. You want to make sure that you don't, by operation, take the pressure up to 16 bar and then have water jetting out at different places. Then what are the performance, accuracy, performance, life of the instrument, stopping overflows from the system? What are the performance expectations in your system that you need to define? And last but not the least, the installation condition, because when you have a wastewater network, you have methane gas present, you have hazardous area explosion risks, which need to be considered in defining your monitoring technology. Because nowadays in cities, you might well go for sewer monitoring programs, and then you say, where is my sewer surcharge? It is, you know, it could well be surcharged in many places. What are the flow rates? What are the limitations in the sewer systems? So the installation conditions need to be viewed and defined so that you get optimum life of your measurement equipment. Now in terms of SCADA technology, running cost, as we said, you have to have telecommunication to back up your remote measurement. So the remote communication capability and the running cost for that is an important factor, how you are going to build it into your administrative environment. Because we have seen cases where the budget for payment of telecom has run out, and then all of a sudden a system that is working quite well is not operational simply because the data cannot come, somebody has forgotten to pay for the telecom services that are used. So we need to be mindful of having, you know, not only building it, but making it sustainable in terms of operation. Then viewing locations consistently. You are putting, you could divide, you could divide a smart city into different zones, different metering areas. Then you have different operators taking care of each area. When you design a control system and monitoring facility, it should be consistent with your operating philosophy. Then including outsourced operations. And then you can actually get, there's a lot of data going into these computerized systems. Flow measurement from here, flow measurement. You can look at what is the per capita water consumption. And these things can be automated from computerized system without you having to go and derive all this data in a manual process. So a lot of KPIs, key performance indicators, can be derived from the control systems. So anybody who wants to install an automation system or a measurement system, we would do well to think about how do I want to use that information, and to what extent that usage can be inbuilt into the system, so that I don't have to put laborious plotting and tracking and information analyzing efforts. So this is broadly the use of the systems. And one important thing here is, in any project construction, by proper selection and proper priorities, you can make sure that the project does not face cost and time overrun. In a case of, I gave an example of a large dia flow meter, which could be a problem contractually, and that could lead into a cost and time overrun. So by looking for a technology which is very simple and it can be installed online without disrupting your process, what you might do is you might help the contractor to avoid a claim, execute his work quickly, and move forward. And another important factor from a system point of view is, a new smart city development, for example. Chennai is a smart city developing as we speak. What could be done is to bring the measurement automation systems early. You are not putting measurement and automation into new infrastructure. You are putting them on existing infrastructure platforms. So at the beginning of your development, if you are able to record your water consumption in different area, or how much wastewater is coming, how much you are treating. Then as you progress with the project work, you are actually setting up a benchmark and seeing whether you are having a reduction in non-revenue water. You have that means to see only just by putting a sequence. Otherwise what happens, like I did, instrument very easily, there are very good easy to use technologies available. Put the metering in place, put the remote monitoring in place, and enjoy the benefit of the data as you improve your water infrastructure. Then you will know that you are actually getting the benefit out of the investment. See, this is the two technologies that I mentioned briefly. You can have large, these electromagnetic flow meters. They are well proven, tried and trusted metering option. You get pretty good performance accuracy, long life, low maintenance, excellent instrument, but it has got a low, it's got a low velocity limit. It, if you reach 0.5, 0.4 meter per second, the accuracy of the measurement starts to decrease. And then, if you want leakage detection and you want to measure your nighttime, quiescent time flows, and say that is what is contributing to leakage or losses from my network, the meter itself may not be sensitive enough to give you what you are after, leakage of water from your network. So you might want to use a meter which has got excellent low velocity, 0.2. I have done some measurements in my city, Coimbatore, and we find a lot of time the velocity in a water distribution network is about 0.2 meter per second, 0.2, 0.3. So knowing your network, select your metering technology so that you can actually measure the velocity. In such cases, ultrasound technology will give you much better low velocity measurement, because just by the operating principle, this is the case. And ultrasound, of course, the old pipes which we have in our infrastructure, other than concrete pipes, we must take care of what we apply where. Mostly in metallic pipes and all this, or plastic pipe materials. Ultrasound metering, either drilled inserted sensor or clamped on sensor, are much more easy to install, easy to maintain. They give a better low velocity performance. And as size increases, above perhaps 400, 350, 400 mm, they become more and more economical. If you reach 1 meter, they are substantially more economical than electromagnetic metering. So everything has a place. Just, the idea is the vision for consultants, end users should be to make sure that they put the right instrument in the right place and make sure that they are able to visualize the construction difficulties that will come by specifying something, which will come back to bite them. No, I'm in a hurry, I must push the document out, it needs to go. You will push the document out, but later you will get the time when the contractor is sitting to solve these issues and find solution, because we should work with the appreciation that we are looking at old infrastructure, and any solution provided should be feasible for that infrastructure. So this is just an example. Dissolved oxygen measurement, you have different ways of doing it, different technologies. Hydrogen sulfide monitoring in a treatment plant, you have different. So any measurement, you have different technology option. The note is, please challenge whoever is your designer to say that he has got the construction perspective as well as the technology. Many times you put a flow meter thinking that your pipe will flow full, and then later you find that you have partial flow in your pipeline and the meter is not viable for that. Nothing is not the instrument's fault, very good instrument, very viable, well applied for similar installation, but in that specific site condition, it is not the appropriate instrument. So there needs I've heard this often from water users in our country that, oh no, measurement does not work, control system SCADA does not work. There is always a reason. You are talking about proven technology across the world. These things have worked everywhere. They should work for us as well. And apparently we don't have a choice now. and our users want to move forward in technology. We just have to make sure that the pitfalls, the ingress protection of the equipment, you put something in a chamber and that gets submerged in water, obviously the life is going to be affected unless you specify that it should be taken care of. So these things, please take care in the specification is the message that
Professor,
we would like.
is it possible if we could little rush up
Yeah.
of the time? Yeah.
So we have the technology, in terms of system architecture. I will rush through the couple of. Now we were about to go into, and actually my colleague was going to speak about the technology part in terms of the computer systems. I think for paucity of time, I will just get on with it. Ram has been my companion in the last 15 years in terms of automation and measurement and management internationally. So he was going to take us through technology. But anyhow, I will just run through it as quickly as we can. Now, when you divide your city into operational areas, and you say, I will put a monitoring system for each area. Effectively, what you are doing is you are breaking up your data on the city into different islands. So you have, I don't know, Tambaram as one area, Saidapeta as another area, and then you have all these islands of information, which becomes cumbersome to integrate. And then when you have different systems coming, there are so many manufacturers who provide good solutions. If you get solutions from n number of different manufacturers, later the owner has to live with the technology for the life of the system. So there is an operational cost to be considered. So in defining the monitoring and control strategy, it is always good to try to come into one integrated system from which anybody can use. That way, all the information is coming into one channel. All the end users can get the owner can get information on how his system is working. The operators can do their job well. So always, try to avoid a fractured system is what we'd like to suggest here. And of course, these are standard aspects of monitoring and control. The graphical user interface. How nowadays, something goes wrong in your infrastructure, you can get an SMS. What is the total water consumed in a day? You can get an SMS. You don't even have to look into anything. The system can come. And then with web-based technology, you can look from anywhere. You can look from home or wherever you are. In the middle of a meeting, you can look up what has been my water consumption last month. It's very easy to, but please look at it from the user's perspective and what information needs to be delivered. Not just as a system with Windows operating system or so and so hardware server, and these are all technology parts which will fall in place automatically. As industry users, we need to define what is it that we are trying to achieve from the system in terms of either wastewater treatment or water management. This is the concept that we need to bear in mind in writing specifications. So there are different ways of presenting, and even now you have ways of generating maintenance work requests automatically based on an equipment failure. You have ways to track, I have 200 pumps in my system. How many have failed? How many have remained failed without any maintenance for the last 6 months? All this information can come to you. What is my total energy consumption? All these parameters can come to the user so long as it is defined and the contractor is obliged to deliver you a system to that specification. So these are many examples of information that a water network can give you. Mass balance subjects, water level subjects, overflow from tank, total water consumption, comparison between different areas, increase in flows month to month, which is indicative of increase in leakages. You got to use every trick that is available at your disposal from a system to warn you. One person sitting at a terminal in a control room and looking, there are limitations to what he can catch with his eye. You have to write the code and get the system to deliver as much clear, concise management information as you possibly can. So that's what we are saying here: energy consumption, water consumption, leakage, and all this stuff. And analyze, the system itself can do a lot of analytics and the water consumption pattern now is different from that of last month. You use these analytics in your system. So that's a brief overview of how to manage an instrumentation and automation project construction system. Now, let me conclude with a statement that reducing leaks and reducing non-revenue water is not something that we do only for ourselves. We don't do it only for ourselves so that we have more water available to waste 24/7 from our homes. That is not the vision that our water leaders are working towards. The vision that the nation works towards, I suppose, is that water is a requisite for all of God's creatures. And we have no right to waste it and deprive other creatures of a livelihood. So on that note, I would like to thank you very much and thank the chair and thank the organizers for the opportunity. Much appreciated, and yeah, I'm happy to, if there are any questions that we can address, I'm happy to do that.
Thanks very much, Mr. Prasad, for a very nice, very in-depth presentation on SCADA. Could you please make maybe one or two questions quickly, please? Yeah.
So, do you have any online COD or POD measurement systems?
There are online COD and BOD measurement systems available, yes.
And how accurate are they? Because usually it is very difficult because it works in a range. So I come from brewery, so it is roughly in the range of 5,000 to 6,000. At the inlet, at the outlet, it will be less than 250.
Yeah.
So the accuracy would be definitely more than 98%.
Yeah, the accuracy is achievable. The measurement, see, there is a small difference between, for example, flow measurement and quality monitoring. Flow measurement or level measurement, they hardly need any maintenance. When someone installs an instrument and hands over to you, you are happy. You cross-check in your lab and say, yeah, my COD, BOD readings are matching and everything. After 2 weeks, you say, no, the instrument is not doing its job. Please, when you move forward in technology, make sure that you have the support available to take care of the instrumentation. Whatever it is meant to do, it will do, so long as you give it the ambience to perform.
Thank you. Thank you very much, Professor and the audience. Because of paucity of time, we go.